All right, fantastic. So he gave the introduction, so we're going to skip that slide, especially because my picture looks even more bald than I actually am. So I'm going to start this by, so first of all, we don't want you to think about infrastructure, but I do want you to think about architecture here, right? And I want you to think about architecture in a very specific way. And I'm going to start with a business scenario that I think a lot of us who travel deal with all the time, right? So if you're on a flight, you have a tight connection, you land, you take your phone off airplane mode, you're frantically refreshing the mobile app, you see that you have a gate change, right? Shit, I have a 30-minute connection. This is going to be tight, but maybe I can make it, right? Run up to the gate agent, say, I haven't been in this airport before. Where's my next gate? She says, well, you don't have a gate change. What are you talking about? Right? And looks at you really funny, like why are you talking to me? And so you're like, okay. You run over to the board in the airport, the big screens. You search through the tiny font and finally find your flight. And lo and behold, it doesn't look like you have a gate change. So you run over to your original gate. And then the gate agent at that gate looks at you like, what are you doing here? You just wasted 10 minutes. I don't know if you're going to be able to get to the other terminal on time. You do indeed have a gate change, right? So now you're super confused. And so you run over to get to the train to the next terminal. You're kind of standing there. Everybody thinks you have to pee, but you're actually just trying to run, right? You get off the tramway. You book it to your next gate. You're looking at the defibrillators on the wall, and hoping that being glad that they're there and hoping that folks don't have to use them, right? And you finally get to the next gate. The boarding door should be closed by now. You've sort of resigned yourself mentally to waiting for the next flight, or giving the loyalty program of your choice a call, and it hasn't even started boarding yet. So now you're super annoyed, right? So this is a scenario that happens all the time. It actually happened to me coming here from Chicago to Zurich, and this is not necessarily just a customer service problem. It is a massive customer service problem because that's super frustrating. It's frustrating for all of us, right? And it's also frustrating for the gate agents. They're not sociopaths. They don't want to give you wrong information. Maybe a few of them are, right? But most of them ultimately want to help customers, and they're frustrated that they can't, right? That gate agent can't tell you that you have a gate change if she doesn't see on her screen that you have a gate change. So this problem is entirely a problem because of the underlying architecture underneath most airlines, right, and airports. And this is true of banks, insurance companies, travel and hospitality, virtually any industry that you can think of. There's a lot of these same architecture problems where an asymmetry of information or different people having different information at different times ultimately causes really either negative customer service scenarios, or it can cause huge cost and transportation disruptions, right? If the agents don't know that there's a maintenance issue on the plane, or if the pilots don't know that they've been rerouted to a new gate, that means that the plane turns around slower, and ultimately that's the biggest driver of cost in the air travel industry, right? Is actually once the plane lands, disgorges passengers, gets the food and stuff back on, gets cleaned, gets checked by maintenance, takes back off. That time that it's sitting on the ground is basically wasted money. So the faster that you can get that done, ultimately the more profitable of an airline you are. And this is a situation that is actually abysmal for most folks in this industry, right? So how do we fix that, right? How do we get to a point where we have fixed the underlying architecture problems so that we can focus on profitability, cost, and customer service? Because ultimately, with the existing architectures, and we're going to show you this in a bit, it's actually impossible to deliver a different customer service scenario. So I'm going to transfer it here over to Austin for a moment, who's going to tell you about how we're going to go about tackling that problem and what are the components that we need to do so.
The way we solve this problem is we came up with an architectural pattern. It's called RED, and that's largely what this talk is about. And it's pretty much an event-driven architecture. And event-driven architectures have been around for a long time. We've been practicing them for decades. But event-driven architectures are powerful. They're a powerful way to write systems that can react to change and information coming from all areas. And in a modern world, of course, change happens really fast. Things are moving faster than ever. And event-driven architectures can handle this better than anything else that's out there. But the reason why we're revisiting this concept and looking at event-driven architectures again is because we're factoring in new software, modern software and modern learnings. And this is kind of the result of mixing these modern learnings and modern software into the event-driven architecture is RED. And we think it could solve a lot of problems. We're going to illustrate kind of the before and after in this talk. And what we're going to talk about is just looking over the challenges imposed by the incumbent architectures, the airlines as we know it today. And then we're going to talk about how RED could solve those problems. And we've got a few pretty wild demos that we're going to attempt to pull off here that the great folks at Accenture and my company have put together. And we're going to also talk about opportunity that this creates. So it's not just about solving the problems that exist today, it's about creating more possibility for the future. And with this architecture, the event-driven architecture with decoupled design, with data in flight that anyone can reach out to and act and analyze, there's a lot of potential to innovate new features, to build more resilient systems. And so we're going to dig into all that.
So the problem that we showed a minute ago, essentially in system view breaks down to something like this. Right? The operations center sends that there's a gate change. That gate change announcement comes from the operations center into the core systems at 2:30. Since the core systems are a little slow, there's a lot of batch processing going on there. Stuff will go into an operational data store, then go into a queue, then go into another queue, then go into another queue. Airlines really like enterprise message queues, by the way. It's like they think that they have superpowers or something, because every time I've seen the core architectures, they have lots of hurry up and wait with data, which I actually find kind of funny, because we have Conway's law, right, that says that every architecture will inevitably look like the communication structures of the organization that built them, which means that in any air travel situation, you stand in a line to stand in another line to stand in a line to sit down to stand in a line to leave. So at least they're making their information do the same thing. But that creates a really frustrating customer experience in that that gate change announcement gets to the mobile phone in only a couple minutes, because that's the latest channel, right? So they get it 10 minutes after it's been issued. But the gate agent, the board in the airport, all of these things get the same information later, and this ends up causing that exact problem that we opened the talk with. So, like I said before, these folks would love to have a better customer experience. The technology behind them won't let them, right? It's like trying to win a marathon and carrying around a 200-pound backpack. It's not gonna work out so well, right? You're handicapped from the beginning. So, what does this look like in the new world, right? In this very event-driven, streaming-driven world, right? And we think it looks something like this, where the moment that the update is pushed, you'll get, of course, slides are always fun. There we go. The moment that the update is pushed, it's streamed out to all of the interfaces all at once. And everybody gets the same information all at the same time. They're able to have the same context at the same time, so you can create a better customer service situation, right? If everybody has the same information, they can act on the same information, they're all in a better place. So that ultimately will solve the first challenge of getting real-time data to everybody. But there's really a lot more challenges in this situation, and we're going to walk you through the next one here as well.
Yeah, Matt did a great job of illustrating how poor customer experience comes from poor architecture, and that's kind of what we just saw in the previous example. And the first way we're going to solve this, the first part of RED, of course, is event-driven, and that's like one of the key components of this whole architecture. And in this architecture, change, data, information is first expressed as events. Everything, events first, in flight, not data at rest. And every component in this architecture, every single module, piece of logic is an independent actor in this system, totally decoupled from everything else. And when something changes internally or externally, an event is going to be published into this system, and all those systems are going to react to it based on whether or not they're subscribing to those events. And one thing that we're mixing into, one new concept that we're mixing into this older notion of event-driven architectures is this thing over here to the left called cloud events. This is a new CNCF project that a lot of important companies are working on right now, like Google, IBM, Amazon,
serverless, Accenture.
Azure, serverless, Accenture. And it's basically a event envelope, a common event envelope. So in this world that we're entering into, I think event-driven, we believe event-driven is going to be increasingly important. Building systems that are reactive, that could respond to change in real time. Building systems that could perhaps autonomously make their own business decisions in real time without humans having to be involved. And in this world, events are increasingly being transported across environments. And we created cloud events because it helps the portability of event data. All cloud events is simple metadata that ships with your event payload. And it has common properties that you could use to generically route the event as well as process it. So there's one property there that says, event type, user created or flight delay. There's another property in there that has the event version. There's an area for custom properties where you could put like tracing information, application specific information, correlation information about that event, a whole bunch of stuff. And the goal is just to create consistency around the event data itself. And that in itself is really powerful because it's a stable foundation on which we could build a larger ecosystem of tools, all types of stuff like event routers, SDKs, all types of tools to help us process events more easily. And again, the data portability here is one of the big value propositions of this. And as a developer, it's just the most fantastic thing to just know what the shape of your data is going to look like and to have those properties that you can rely on at the end of the day.
Fantastic. So a couple of other things here. So really, when we're talking about basically changing the face of the airline and airport architecture, it sounds like a really complicated thing to do, right? And in some sense, the business logic can be somewhat complicated. Some of the operational metrics and things like that are somewhat complicated. But on the application level, on the level of actually encapsulating that business logic and pushing it out, there's really only 4 components. There are the microservices, which are larger containers of business functionality that are independently deployable. There are functions, which are little serverless functions that are reacting to events and have a slightly smaller payload of business data. You have the event stream. You have the event gateway, which is something that our friends at Serverless actually put out there as an open source project. It's a CNCF project where you're able to actually route these events between different clouds, different organizations, et cetera. You have the reactive interaction gateway where we can route events back and forth from different user interfaces. And we have the event streams, which we're publishing events to and subscribing from, right? And with a mix of these 4 components, we can actually create incredibly intricate systems that ultimately are this sort of big horizontal layer that you can just sort of continuously append to and add on to. And we'll talk a lot more about that in a moment. But first, we're going to try our first risky moment of the morning here, and we're gonna see if we can get the demo to work. And I keep forgetting that I have to exit PowerPoint to do that. Now we will go ahead and prove that this stuff actually works. So let's go ahead and take a look at our flight here. Of course, I managed to do that. So there we go. Airport operations. Let's go ahead and sign in. Okay, we can see our flight. It's on time. So let's commence messing with the. We're gonna look at gate A4 here. Now we're gonna commence messing with the passenger. You guys ready? So we're gonna take this. We're gonna edit it. We're going to do a quick gate change here. We're gonna change him to A6. We're gonna update the flight. Okay. And now we've got the notification that the gate change happened, right? And an interesting thing here is that if I look at the gate agent UI here as well, I probably have to refresh that one because my token ran out. In any case, if I look at the gate agent UI, the same thing will happen if I didn't get the token refresh. Yay security tokens. So the cool thing here is that the different environments will get the event all at the same time, right? So you saw it was pushed immediately. You don't have to refresh the app. You don't have to sit there and wait, right? You get your gate change information immediately, which ultimately we also have the board in the airport UI, which I didn't show you, but in the interest of time, we can show it to you afterward. This stuff is all public. So from there,
Let's open up that tracer view too.
yeah, let's do that indeed. Let me make sure I actually have it here. We're gonna have to go into.
Okay, I'll just start chatting about this while you bring that up.
Fantastic.
So it's a fairly complicated architecture, or at least system that we've set up here. We have an on-premise environment that is actually hosted by the airport itself. That's publishing events up to this event gateway. The event gateway is routing them kind of back through the on-premise airport environment as well as to an airline in the cloud. And it's doing this a lot via our product called the Event Gateway. And you can actually see the events as they just flow through the system here in the Event Gateway. You first saw the gate change event come in from the airline, and then the gate was updated in the airport, and that actually populates all the displays in the airport. And one thing I want to chat about here is, if you could pull up that next slide, is the thing that, I think when I keep thinking about this architecture, the thing that really gets me excited and gets me out of bed in the morning is this idea of information democratization. I'm sure all of you have had this experience, but it's like when you start collecting data and you collect information, it tends to get siloed. It gets siloed in some system, some database somewhere, some SaaS product that you're using, and information also gets siloed in a team, right? But in this type of architecture, events, everything is expressed as an event first, and those events are in flight, and anyone can reach out and actually access those events to make something happen. And I'm obviously a big fan of serverless architecture, serverless computing, and what I love about that is like I got into programming because I want to amplify my ability. I want to be able to do more, and that's kind of what what programming enables. And the serverless speaks to that very, very well. It's never been easier to write some code to respond to anything that could ever happen, right? You write some code, you put it in an AWS Lambda function or a Google Cloud function, scales automatically, only charges you whenever it executes. It's fantastic. Now we could all of you can go home and write 1,000 functions today. You're not going to be charged anything until those functions run, and they're going to scale to meet any type of load, almost any type of load. But now the question is, how do we get data to this new powerful compute? Right? How do we get events to this new powerful compute? Because that compute is also all event driven. And that's what this architecture also seeks to solve. And things like the event gateway. So again, when your data is expressed as events first and flowing through the system, anyone could reach out as long as they have access to that, and they could say, hey, I want to write a subscription to that event. I want to make something happen in response to that. They can go write a code, and I'm actually going to try and deploy a new service to this whole architecture towards the end of the demo to just add to it in real time. But again, anyone who has initiative, anyone could work with autonomy to go, affect change in the organization and do something interesting.
Excellent. So I want to tell another kind of interesting story here, and we'll continue our industry theme. Often enough, the incumbent architectures not only have the problem of not getting the information to the right people at the right time, creating silos of that data, not being particularly easy to append to, programmatically speaking. They're also often incredibly brittle, incredibly failure prone, and incredibly prone to single points of failure. Right? So I'm gonna obfuscate the story a little bit to protect the innocent. But so there's an airline who fairly publicly a few years ago had an outage. Right? That outage was caused by somebody forgetting to plug in a UPS in the data center. A whole section of infrastructure went dark. They brought it back up in about 2 hours, got everything nominally running, but it grounded flight operations for a couple days. Right? Gigantic problem, huge mess in the transportation infrastructure in the country of origin. Right? And all of this comes back to not plugging in a piece in the data center, but it's actually more complicated than that, right? Because what you end up getting when you have this is everything goes into all of these queues, right? So you have a flight delay, gate changes, crew delays, crew changes, captain's sick, right? Drank too much the night before, got to change the crew. You've got different maintenance issues and all of that. All of this goes into these queues of data to update different interfaces and update different employees, update passengers. If you take a piece of that down for a couple hours, you're essentially filling it with garbage data. right? Flights that have already taken off, delays that have already happened, gate changes that already happened that are no longer relevant, but they're not able to go anywhere because you've taken down one of the pieces of the infrastructure where they actually need to flow through, right? So it took these guys a couple days to actually get this thing back up and running operation because of this exact problem. You can't drain the queues because then you're going to strand people at airports. But you're also going to strand people at airports if you don't drain the queues. That's a kind of a terrible position for everybody involved to be in, right? So when we look at this, when we look at the solution to this, ultimately we can solve this with the same components that we solved the real-time and event-driven problems with, and that is the event streams are incredibly scalable. You look at something like Apache Kafka. There are folks like Uber and others that are pushing 1 trillion messages an hour over a single cluster. That's sort of ultra scale, right? If you find a use case that has more scale than that, let me know. And the same thing is true for Google PubSub. The same thing is true for Amazon Kinesis. Then microservices, of course, are stateless units of compute. So especially with Kubernetes, you can spin up new copies of the microservice horizontally to take on new load. Functions are even easier to do that. They just do it sort of automatically as more load comes in. The data stores in the background, we can have geographically distributed multi-master stores that create consensus on transaction order, right? It's something called the Raft algorithm, which I won't go into detail here because we could have a whole presentation on that, but it's really cool stuff, right? You have things like CockroachDB and CosmosDB in Azure, right? Yugabyte, there's a number of these that do this. And then, of course, you have things like Rig and the Event Gateway, which are built on scalable technologies their cluster sizes will increase as the load comes through, right? So if we, say, turned off a whole availability zone in AWS where this stuff is running, the load will balance across the rest of the system. And since most components have copies of the transactions in flight, we really won't lose a step. Right, which you contrast that to the more traditional environment, where if you flip over one piece of the infrastructure, it creates a butterfly effect that ultimately creates a hurricane, right? And it's no fun for anybody. So, what this really provides for us, when we think about it, is the ability to build this kind of architecture with these tools for more critical infrastructure. Right? All of this is all well and good when you're Netflix. Netflix is awesome, right? But if you press play on a TV show and it doesn't work and you press play again, everything's fine, right? If you are a hospital network, or if you're a country's health infrastructure and you have an ambulance racing with a donor heart in a cooler, and that cooler is reporting temperature data, if you lose 5 minutes of temperature data, what could happen to the person who's going to get that donor heart, right? If it went over temperature, so it's all fun and games until somebody's life's on the line, right? The cool thing of why we're able to do this now, and why we're really talking about this in the context of enterprise and critical infrastructure, is that though the patterns have been around for a long time, the tools are fundamentally capable, especially when architected correctly, are now fundamentally capable of supporting the same kind of very scalable, elastic, event-driven goodness in really critical infrastructure like core banking, healthcare, et cetera. So we have the opportunity to sort of have our cake and eat it too, right? Where instead of this stuff being restricted to a bunch of media companies, and media is not critical infrastructure, right? Sorry, California, but it's not. We can move it to the industries that if they went down for any amount of time, it paralyzes whole cities, countries, et cetera. So we can now push the same kind of architecture into these industries. So we're going to change the persona a little bit here, and Austin's going to tell you about the frustration from a whole different angle as we talk about actually making this stuff real.
Yeah, let's talk about speed to market from the perspective of a CIO. Every CIO has to figure out how are we going to make the best customer experience possible, right? And make something that actually works and is resilient at the end of the day. And with many of the legacy kind of monolithic architectures that are tightly coupled, it's really hard to innovate, make change on that, because whenever you touch one thing, you risk affecting the system as a whole, right? And you want to get out of that pattern. And of course, with this event, with the red architecture, everything is decoupled, right? Every single module, everything that has your logic in it is totally separated. And because everything is subscribing to events independently, anyone could go update something, add something new at any given time without affecting the system as a whole. And again, this goes back to kind of that information democratization theme that goes back to just creating autonomy in your teams, right? There's a lot of great people, at least, I see all over the place in a lot of companies that we talk to. And they all want to make stuff happen, but they're just blocked, right? And they're blocked by monolithic architectures. They're blocked by lack of autonomy. And we want to enable that as much as possible. And so that's what this is about. Largely, I'm going to try and illustrate this right now with the next demo. First, Matt's going to kind of go over how this is decoupled.
Excellent. I'm going to give Austin a little bit of air cover to start setting up his demo, and then we're going to do something a little bit more risky again, where we're going to switch the video over and then hope it doesn't crash things on the computers. So, and if it does, we'll work through it. When we're talking about decoupling and making sure that these are autonomous components, once again, our four heroes come to the rescue. We have our microservices and functions. Those are, of course, independently deployable components. They don't, especially when they're just emitting and reacting to events, they're not talking directly to other services. Right? I have another talk that I like to do where we kind of show what the old architecture looks like when you have everything talking to everything, and you end up getting these complex sort of daisy chains of functionality that I like to call it's the telephone game set to technology. Right? So when one system says something to another system, transforms the format, transforms some of the data, and it goes on and on and on, what is the likelihood that that message is actually going to end up in the right order with the right components? Very little, so you have to build all this complicated testing scaffolding around it. You don't really have to do that here because each of these is just emitting events and then reacting to the ones it cares about. So as long as you're not fundamentally changing the event format, et cetera, you don't have to go test everything else. You just add functionality, which is something that Austin's going to show you in a second. The event gateway, of course, allows us to send these events between different locations and not have them, once again, directly communicate with each other. And since that's scalable, it's not a single point of failure. You can go kill nodes, and it's not gonna drop on you. Same thing with the rig, sending it to interfaces. Right? This is an actor-driven component, so you can go kill nodes. You can push new routes, et cetera. You're not going to affect anything else. And then the event stream. Event stream itself is a very scalable component, and you're just appending events to this very, very big pipe. Right? So once again, that's not going to impede you in any way, like if you were publishing to another service directly. So all of this stuff is autonomous, separate, all that good stuff. So I think now we're going to. We have one more thing, then we get to the demo. So. What this allows you to do, in fact, actually, I'm going to switch it up a little bit. We're going to do the demo first, then I'm going to talk about this because I don't want to prejudice the outcome here. We'll see how it works.
All right.
All right. Live coding is always fun on stage, right?
Well, we talked a lot about autonomy. I certainly did, and I feel like I got to make it real. So we built this architecture. Half of it's on-prem, the other half's in the cloud. And here I am on stage, and I'm going to try and add a serverless function to the architecture in real time. And the scenario here is Matt's going to go publish the flight delay event, and I'm going to write a function that it pretends right now, I haven't actually written the logic in the function, but it's going to pretend to go look at all the passengers who are in that delayed flight, and it's going to scan and see if there are any high-value loyalty members in there. And if there are, it's going to publish another event back into the system saying these customers, these loyalty member customers were affected. So I'm going to try and do all that in real time. The way I'm going to do it is I'm using our project called the Serverless Framework, very popular open source project for building serverless architectures. It's become kind of the go-to tool for doing that. And the Serverless Framework really has kind of two simple concepts. It just thinks of building these systems in the terms of functions and events. So I have a single function here called the process customers function. and here's the line of config that's pointing to the actual logic in that function. And then every single function in this YAML file has an events property. And here's where I could just add all the events to subscribe to. I have one test event that I forgot to take out when I was testing this thing. But you can see right here, I'm subscribing via the event gateway to the com.red.air.unicorn.flightDelay event. And I'm going to try and deploy this thing right now. So the serverless framework is just a command line interface. And I just deployed it. And now we're going to go back to that tracing view. And we're going to try and see this work in real time. Praying to the demo gods and all that stuff. So Matt's going to try and emit that flight delay event, and hopefully the function is going to react to it. The function I just deployed is going to react to it. It's going to pretend to process these high-value customers and then publish a new event containing those customers. And there we go. We saw it work in real time. So via this little tracer app I built for the demo, again, this is actually another decoupled part of the architecture. I just wrote a serverless function that is subscribing to all the events in the architecture, it's saving them in a DynamoDB table, and I built this little front-end app that's just requesting the event log from the DynamoDB table. So I can actually click on these things, and we could look at all the events we've been putting into the system. All this is using the Cloud Events format, which I'm using to generate kind of these top-level titles. And then here are the payloads that were in the events. Here was the original gate change one from the first demo, the gate updated one from the first demo. So Matt just published this. That's the flight delay event. And again, my function processed that flight delay, pretended to look up the passengers there, and then published a new event into the system. So again, an example of autonomy. I just added a new function to the architecture. I didn't have to go talk to any of these folks or really interact with them to just go make something happen. And further, look, I just created this new event, this new piece of information that's super valuable. Sales team, marketing team, customer success team could go look at these events. Heck, they could, if maybe they become programmers one day, they could write functions to react to all this stuff. They could write marketing automation. They could write notifications to someone who's, managing the accounts of these people or something to go reach out to them. And all this stuff is really, and again, this is all in event-driven architecture at the end of the day, but because we have this new stuff, it's becoming more accessible than ever. And this is what the Red Project's all about. And this new stuff, again, is a cloud events format. It's the serverless technologies, and all these things mixed together. So, event-driven architectures, I think, are going to be a bigger future in the theme, especially when you think about IoT, when you think about building systems of intelligence, when you think about serverless compute, which is event-driven. Again, never been easier to write code to react to anything. And now these tools are all making it possible.
And it's not restricted to one industry or another. We're doing this stuff in banking, in insurance, in travel, in hospitality. And there we go. The demo gods or the AV gods are still with us as well. So we'll make an appropriate sacrifice to both them and the demo gods after the presentation, hopefully. So I want to make two additional points here, and then we'll keep going. Once again, this stuff has been around for a while, but it hasn't really been applied to distributed architectures in the way that it is now. And it hasn't been applied in such a way as we can really begin to tackle some of the legacy system problems that we have, right? Actually building a core banking system or something like that is intricate and sort of building the plane in the air, as it were. It requires that decoupling discipline to be able to start hollowing out and scooping out core functionality by piece to move it around. And just a quick advertisement for one of the other presentations. Right after this, one of our colleagues, Simon Kistler, is giving a presentation on how to actually take what is an existing mainframe application and move that into a red architecture, right? For a very big company, right? So this stuff is moving faster than we think it is. And one of the points that I often make when I go talk to CIOs, when I go talk to COOs about this is like, look, most of us, and when I say most of us, I'm talking about the C-level folks, have MBAs, right? We all learned like the book Good to Great, which was this book that had all these supposedly great companies with DNA of what made great companies. Only a couple of them are still around, right? The rest of them were put out of business or what have you, or acquired. And obviously what they thought made them great wasn't what made them great, right? And it may have been that was the case at the time, but really they failed to be able to evolve with the changing marketplace. And every company is becoming a software company, whether they want to or not, right? Your choice is to become a software company or ultimately find a fire sale somewhere and go start selling off assets, because that's essentially where we're at these days. And one of the sticking points that often gets brought up when we talk about all the cool new components, moving everything into the event-driven world, is that a lot of the administrators get nervous, right? They're like, well, how do we operate this stuff, right? Is there an operations architecture behind it? Can we trace events? Can we do all of this stuff? And the answer is yes, and Austin's going to tell you a little bit more about that now.
Yeah, a few key parts of operationalizing this type of architecture. First off, it's adopt open source standards whenever you can, like this cloud events format. That effort is still early. We were accepted into the CNCF, I think it was June this year. But again, the stakeholders that are involved there, it's pretty much every major cloud company, Accenture, of course, our company. And it's a lot of industry influencers in there. And I think they all share this common belief that the future is going to look more event-driven. And amazingly, they're all kind of buying into this single event format. So adopting some type of standard there, I think, is going to be important, because the tooling is going to be built on that. We just needed that stable foundation, that stable event format. And again, in that event format, you could put tracing information, you could put any type of correlation information. There's a lot of talk right now within that working group about integrating cloud events with some of the other kind of metrics and monitoring and analytics tools and efforts that are going on in the CNCF. So we'll see that emerge shortly. You could use that, put custom metadata in there for correlating events together, so you could see, these events all came from this related thing. And also, runtime SDKs. So looking into the runtime, Cloud Events is going to have SDKs shortly. We're going to finally make that effort stable in December. And with that, we're going to introduce the first SDKs so that you could easily publish, process events from anywhere. Furthermore, looking into routers like Rig, like Event Gateway. Also looking into lifecycle management tools. That's another big part of this, like serverless framework. And kind of where this goes in the future, I think, we're starting to see some more SaaS companies get involved in that cloud events working group. And I think what could be common in the future is, right now when you interact with any other kind of software or any other system, it's usually all API based, it's all request response. I think in the near future here, a lot of that's going to become event-driven. So, for example, if you just want to get a webhook from GitHub or Stripe or Salesforce or something like that, it's going to be an event that's pushed, and you're not going to have to go make a request to call out to that. So there's some work going on in cloud events to create kind of a common event registry to kind of try and define all the events on the internet and help enable companies to kind of add their own events to that. So as developers, you could just go look at what's on Stripe or GitHub or kind of any other company's system and say, yeah, I'd like to subscribe to that event and I want to write some code, microservice, a serverless function to make something happen with that. And all that stuff is being enabled by cloud events. And again, look out for the release. I think it's going to be in December. We should hit version 1. Super stable, again, backed by the major industry influencers. And I think right at that point, this stuff is really going to take off.
Yeah, we're just going to run through a few more things here really quickly. And if you think about it, if everything is being emitted as this big stream of events, right? Machine learning components, other real-time analytics, all of this can hook into it, listen to, emit events, and we can start to get sort of intelligent self-learning systems built from that, where the architecture can sort of evolve on its own as you build new services, build new functions, take some out, add in intelligent services, et cetera. And just so to come back to the total message, these are reactive architectures. If y'all haven't seen the Reactive Manifesto, go take a look at it. Go sign it. It was created a few years ago, but I think the time is finally right for almost all of our core architectures to be reactive. Real-time, event-driven, and decoupled. Just to highlight a couple things, and we're gonna go back and forth here. Some components to check out, and please, if you like them, star on GitHub. We always like that. The Reactive Interaction Gateway is something that our team produced to be able to emit all of these events to different user interfaces, so that they can stream events back and forth. It allows the UI to participate in this wonderful event-driven world. The Event Gateway is...
Yeah, the Event Gateway is something we released last year. It's an open source project. You can go to GitHub/serverless/Event Gateway. And the goal is to be kind of the ultimate event router for the cloud and serverless era. So you could send any data into it via an HTTP request containing the event in the post body of that. And it knows how to route it to an AWS Lambda function, 5 Lambda functions, 100 Lambda functions, an Azure function, Google Cloud functions, IBM Cloud functions, anywhere where you want it to go. We also have support for other sources like directly into Kinesis or Redshift. And all we're doing here is we're building integrations with everything, right? To collect those events from any type of source and route them to any destination with a strong bias towards serverless compute, because again, it's never been easier to kind of react to do anything with events in serverless compute. And again, you could go deploy it right now. Also, if you go to serverless.com and you sign up for our dashboard, you can actually use a hosted version, which we built this on, and it's just really easy to get started with. There's great support for it built into the framework. And lastly, a popular evangelist named Kelsey Hightower did a demo of the event gateway at the last Cloud Native Con, and he has a whole video on how you can get it up and running in Kubernetes.
Yeah, and Kelsey's a great presenter, so taking a look at that is definitely worth your time. And then just last, we've already talked about cloud events. Definitely go check it out. Bookmark the website. Lots of cool stuff is coming. And then the last component that we talked about with event streams. There's a number of popular ones, a number of event streaming technologies that are out there. Go take a look at those. And in the future, once again, I just want to underscore, survival is optional, right? For a lot of the companies that are not moving toward this, they're either going to have to adapt toward the more real-time world, or they're going to have a lot of trouble, right? So the sooner that we all get into this, the better. And for the students in the audience, the more of this stuff that you pick up now, the higher salaries you'll be able to command from folks like Accenture. I see Thomas there like, don't say that. Right? But, take a look at this stuff, think about it, understand the customer experiences that you want people to give you and that you want to build. And we're all going to live in a wonderful event-driven future. So thank you for your time. I think we'll be out there hanging out if you want to ask questions, we always accept job applications. So it's all good.
All right, thanks everyone.
Cool. Thank you very much, Austin Collins for serverless, Matthew Lancaster from Accenture. What's the time? I'm gonna do like everybody's already switching. I know I said in the beginning because they wanted to use all their time for sharing as much as possible. But I see some people still went on a Slido, which is great. But not to disappoint you, maybe we could do like a quick one, gentlemen. I know we said no questions during the break, but I just don't want to disappoint them that some people are actually asking questions.
Oh.
Could you like in 2 minutes answer the first two because they got the most votes?
Voting system.
So good. The first one's a good question, and often enough the source system is going to contain important business logic, right? But as it emits events, or as we grab events out of the source system and throw them onto the stream, they'll contain at least enough context for the right sort of series of events to actually do something meaningful with them. A quick example of that would be if we have like a deposit in the bank. I'm not going to include all of the different auditing logic, all of the different security stuff in that event. What I am going to do is make sure that the deposit amount is able to be streamed to the UI, right? So at least for V1, you get enough information to actually solve the first business case, and then you iterate and evolve from there, right? That's part of the beauty of this.
It largely depends on the use case, whether or not you want to include all that information or have someone go request it from someone else and kind of use the event as just a mere notification.
All right, cool. You want to do the second one? I know people are switching, that's allowed.
I think the fanning question there is actually a really interesting one.
Okay, we'll do the fanning one.
So maybe both of us can comment on that really briefly, but there's all of this stuff is art, right? That's why a lot of us are still employed as developers, and we're not able to have AI do it yet. But in terms of being able to encapsulate flows of business logic, we still need to do good brass tacks domain modeling. We still need to think through it. And as Austin showed you, you can actually trace all of this trace the event flow, et cetera, and publish it so that business users can see it and understand it pretty easily.
Yeah, that's right.
Cool. You want to comment on it?
Also we're looking at adding a lot of features like transformation, validation, right into the event gateway. There's already auth in there too. So that should help kind of have one place to kind of do all that stuff so that when it actually hits your business logic, a lot of that stuff is taken care of for you.
All right, cool. Ladies and gentlemen, I want to thank you again, Austin Collins, Matthew Lancaster, for the great presentation. Give a round of applause.